Hello and welcome to episode 38 of Daryl Show Your Work. And in this video, I'll be covering path interception, which is the risk introduced into code that allows an attacker to execute system commands. However, as always, anytime we're doing any type of red teaming activity, I want to preface this with the disclaimer saying that this is only for research and ethical purposes only, and that any malicious activity that may result of this, I do not claim personal responsibility for and highly discourage. With that said, let's get started. All right, so the first thing that I want to do is I want to change directories to my Git folder, which is where the file that we'll be interacting throughout this video is located. So I'm going to say cd desktop git. All right, and I'm gonna list out that file for us to see. So as some may recognize from my last video, this is a file that we briefly interacted with, which is a source code written in C. And again, this is just the main file that we'll be working with throughout this video. So I wanted to display the contents of this for me to point out exactly what's going on in this file and explain exactly how this attack works. All right, so I'm catting into it. All right, so I want to take a look at lines 47 through 53 here. All right, so we can see a child process is being spawned and either runs DD or RM in order to overwrite and delete a file. Notice they're both using a exe CLP closed parentheses call. This is the standard C function that takes a list of arguments, including the name of the program to run, and then executes that program. It uses the user's $ path variable to discover the location of the program. This nuance allows an attacker to alert what the program does. All right, so trying to think of a scenario. So I'm gonna write out a command here, and then I'm gonna explain it a little bit more. So let's say and I'm talking about this specific thing, this right here. So let's say this, what we see here. Let's say that this is been, see, this is not what we're going to be using, but I just wanted to give an example of how this works so visually I can show um, with an actual directory how exactly this attack works. Okay. So let's say that our $ path is set to this particular directory, and we want to execute the command rm. That's here, right? Let's say that was in this code. All right, rm will be looked for in places listed in the $ path variable. So it's going to look in all of these different directories here. All right, in the order that it appears. So it's going to start here in the bin folder, and it's going to go and go on and go on. So if rm is in the user bin directory, which is here, RM will first be looked for in the bin directory, and then in the myprogs directory, and finally in the user bin directory here. All right. If the user has or us in this case, if we have a written access to or not written access, I'm sorry, write access to my progs directory, we can then create a malicious RM executable that will be run instead of the real one. So let's say that we made our own RM, and I'm gonna show you what that looks like. Let's say we wrote our own RM script and put it in here as an executable. Well, it's because it's looking in order before it ever gets to this directory here at the very end. It's gonna execute the fake one here, which is our executable, and which is going to have malicious code in it, and it's going to allow that code to run because it reflects the actual name of a real file that, or a real executable system executable that we're trying to run. All right, so to show you exactly what that looks like, and I'm going to write a small code that's going to allow us to escalate our privileges. So the first thing I want to do is I want to export everything that's in path. All right, and I'm going to export that to $path. All right, and again, this is to edit the path variable, so our malicious file that we're going to write is to run rather than the correct one. All right. All right, so that's been done. And then I'm gonna move back to my desktop directory, since we're gonna be operating from there. All right, now let's create the script that we're gonna be running. Our RM script, and not the actual thing that's being called here in this line. All right, so I'm gonna say nano because I'm gonna be doing this in our text editor, and we're gonna call this rm.c. So it's gonna be a C script, just like our source code that's going to be calling it. All right, so I'm going to say int, and I'm going to explain each line of this code when I'm done writing it. All right, let me see. I'm going to close it up here. Ooh, okay, so this is a relatively small script, but I'm gonna go line by line to tell you what's going on. So the main thing that's going on here in this script that I'm writing. So this is going to spawn a root shell. All right, and the root shell is what's going to essentially thank the Metasploit framework, and it's what essentially once you have a interpreter session, then allows you to gain an active session inside of the target machine. So here it's going to put this target root shell is going to put us into a root session and allow us to operate as root, which in turn, of course, escalates our privileges because we don't have root privileges right now. So to go line by line to just to tell you what's going on here. So line one here, this is what declares the main function. All right. And in line two here, this is actually what spawns the shell, and line three is what closes the function. So it's a pretty simple script here, but it's malicious nonetheless. So I'm gonna hit Control X to exit, and then Y to save. All right. Okay. So the next thing I want to do is I want to compile this code in order to get it to work. So I'm gonna say GCC rm.c. That's the file we just created. Dash lowercase o rm, and this is going to to compile the code for us. So it's checking my syntax here, make sure I'm good. All right, looks like I'm good to go. All right, so everything appears to be okay. So now we need a test file to interact with. So because the rm is a root, it's a remove command. So we need something for it to delete. So I'm just going to create a dummy file here. Touch. and then we'll call it test. And the touch command is what we use if we just wanted to create an empty file but did not want to immediately put anything in it versus like a nano or a vim text editor. So this is going to create the test file for us. All right, now I'm going to run my source code against this test file. And so what it's supposed to do is supposed to just delete the test file. But remember, it's calling that RM executable as well when it runs. So it's probably going to do what it's supposed to do as far as deleting the file, but it's also going to allow us to escalate our privileges. So let's see if that indeed works out for us. All right. So everything looks right as far as my syntax here. I'm telling Linux to execute this source code, which then should delete this file. All right. Let's see what happens. Deleting file. And look at there. So if you notice this hashtag symbol or this number sign symbol, that's an indicator that we are in fact in a root session. And to verify this, I'm gonna just type ID. And there we go. As you can see, we are root. All right. So um um I guess before I wanted to jump into anything else, just wanted to further explain what's going on here. So this essentially it modified the dollar sign path function, and to ensure that our fake RM file is the current in the current directory is executed by the. And I could go back up to show you what I'm talking about here. So basically, it ensured that the fake RM this right here, this is being executed instead of this real one that's being called here. All right, and it basically excuse me for my blip here, to execute to be executed by this function right here, which is execlp. All right, so basically, because this is in another directory, okay, in a different directory, and I'm trying to find where I wrote that all out for us. Let me see if I could go up and find that. Oh, you know what? I deleted it. But in the example that I gave before, because of the way this function works, it checks it folder by folder in the order that it appears before it got to that last folder where the RM is located. Because we put this malicious RM into a folder that comes before it, it ran this malicious executable instead, and this is what allowed us to do that by writing this and putting this malicious code into it. Okay, so the next thing I wanted to move on to is how can we compromise this vulnerability if we don't have a or how can we at least know that this vulnerability exists if we don't have an RM C file to work with. And we could do this by using a utility called strace, or strace, strace, however you prefer to say it. And it's a small Unix program that intercepts all system calls a program makes, as well as those calls return values. So I'm going to show you how this works. So I'm going to first exit out of here. Okay, so the first thing we want to do is let's remove our malicious RM utility. So we're truly working without it. So I could display how this works. All right, so that's going to remove the malicious RM executable that we created. Checking my syntax, good to go. All right, so that should be gone. All right, and now we need to, since that test file was deleted, because that's what the source code is supposed to do, is delete that file. We need to recreate it. So I'm just go back. All right, and we're going to recreate that test file over again. Okay. All right, so this time we're going to run strace, the utility. We're going to run that along with the source code and the test file. So the only thing, I'm going to go back here, and the only thing I really need to add here is strace. All right, and that's going to run strace along with this. And let's see what happens when we run this utility. So as you can see, this produces way too much output for us to know what's going on. So and a way that we can reduce this is we need to add some flags to it, or one flag in particular, which is a dash lowercase f flag, and this is what's going to allow us to follow any child processes are produced when running this utility. And well, we're running the um the source code, and and reduce the output down for us to be able to more clearly see what's going on, and for me to better be able to explain it to you. All right, so going back in my history, so we're going to add a few things to this. All right, so we're going to add that lowercase f flag here. All right, then we're going to add a few more things. We're going to say then ampersand one pipe. Okay, and then we're going to grep any place where it says ino int. All right, and what int means is error no entry. All right, and I'm gonna explain why we're repping that as I run this, or as this gives us back results. And give it some time to run. Okay, so definitely not as much output as the initial strace command. And so the main thing to understand about what we're looking at here, this is helping to verify that the path injection vulnerability exists, because strace automatically replaces missing executables with safe defaults, preventing exploitation. So we would have run this against the against which we just did against that source code, is basically telling us every place where in the code, or in that particular C file, the source code C file, every line where it had to basically correct that vulnerability. So if we know what particular lines to target, and which particular lines make it vulnerable to to this vulnerability. So if we look here, we can see the one here that we took advantage of, and that's this the RM line. All right, so this was just a brief overview on how path interception works, some ways in which it can be exploited. We first did so by creating our own malicious file to then stick into a subdirectory that basically preceded, because of the way that this source code is run. Because the folder was in preceded the folder of where the actual executable, the non-malicious executable is housed. It allows us to basically run that from that folder, and to then cause a privilege escalation, and which is something we don't want to do. And then we also operated without creating that malicious payload, that malicious RM code. And we did so by using the strace utility, which basically when we ran it, it showed us everywhere in the source code where the vulnerability existed, and then we could come up with different ways in which we can exploit uh, uh, that particular attack vector with this source file. So this is just an encouragement to just make sure that secure coding practices are being conducted, because this is one of many ways that that um, system commands can be executed by a malicious user, whether internally or externally. So that brings us to the end of our video. Please like, share, subscribe. Most importantly, show your work. And until next time, take care of yourself and God bless.